Hello my dear student, myself Sanjay Sharma. I am a physics teacher from Rishikul Vidyapeeth, Sonipat. I am here again with my fourth module of Electrostatics, class 12th topic. My topic is electric dipole. So what is the meaning of electric dipole? Basically, when two equal and opposite charges, negative charge and positive charge, are kept at a certain distance, that is called as electric dipole. But in this case, we generally don't take distance between two charges as we don't take. So what we will take, 2L. To simplify our calculation, we take 2L or 2A. So this combination is called as electric dipole, and a vector quantity with which we measure the strength of the electric dipole called as electric dipole moment, and it is represented by P. And the direction of electric dipole moment is always from negative charge to positive charge. So this is the direction of electric dipole moment. The expression of electric dipole moment is the magnitude of either charge, maybe this or maybe this, because we have to take what? Magnitude. And the multiplication with 2L. So this is the expression for electric dipole moment, and electric dipole moment is a vector quantity. So here we will use vector sign. So this is the vector sign we can use. What is the SI system unit? SI system unit, and the system unit is equals to Coulomb distance meter. Coulomb meter is the SI system unit of electric dipole moment. The very important question arises here: what is the significance of electric dipole? Basically, this concept students they use in chemistry. So I am telling you one hint for the significance of electric dipole. If we have a dielectric may be of two types. In one type of dielectric material, maybe the molecules are already polar, where the poles are already developed. And another one is non-polar. So I am telling you what is the meaning of polar molecule and non-polar molecule. See, polar molecule. So if we have any molecule which is in this manner, where negative part, you can say negative charge is one side and positive charge is another side, and in between it has some distance between them. If this type of molecule we place inside the strong electric field, then what will happen, beta? I am telling you, if a strong electric field we develop, then this type of molecule align itself in this manner, because the positive charge will attract this negative charge and negative charge will attract this positive charge. This kind of molecule align itself inside the strong electric field in this manner. So it means when we place a polar molecule inside the strong electric field, then what kind of duty of the electric field do? The first and one duty is this, only the alignment. But in case of non-polar molecule, non-polar molecule. In this type of molecule, what will happen? See, in this type of molecule, we have molecule just like this, where the center of positive coincide and negative charge center also coincide. Mean, without placing this type of molecule inside a strong electric field, it does not have any kind of poles. But when we place this type of molecule inside the strong electric field, then what will happen, beta? See, if this kind of molecule placed here, then see here what will happen. The positive charge will attract the center of the negative charge, and negative charge will attract the center of the positive charge. Then the shape of the non-polar molecule becomes just like this. So this becomes in this manner. So when we place non-polar molecule inside a strong electric field, then there the electric field do two kind of work. The first one is to make the poles, and the second one is to make it in a proper alignment. I am telling you again, if polar molecule plays inside a strong electric field, then only one kind of work being done by the strong electric field. What is that? Only just alignment. But when non-polar molecule plays inside a strong electric field, then what will happen? Then, firstly, non-polar become polar, the poles will develop, and then alignment also take place. This was the significance of electric dipole. Now we have to come on, how can we find electric field intensity in case of electric dipole and at different situations, at different positions? That I am telling you here. See. Now the topic is electric field intensity at any point on the axial line. The question arises, what is the meaning of axial line? See, if we have an electric dipole, then the line passes through the center of the charges and extended in one direction. Extended in one direction. So this line is called as axial line. So here we can say, or we can write here, this is the topic of axial line. I am telling you again what the topic is. Electric field intensity at any point P due to electric dipole on its axial line. So let us consider an electric dipole. In between distance is 2L. Now consider a point P on the axial line and consider a unit positive charge over there. If we consider a unit positive charge here, it doesn't mean it is present here. We are assuming beta. See, this point may be A and this point may be B. The direction of dipole moment, we all know that from negative charge to positive charge. Then at point B, the charge is plus Q. At point A, the charge is minus Q. See, positive charge will attract or repel to this unit positive charge? It will repel. Yes, very good, bete. So this is EP. This will give the direction of electric field of the charge present at point P. And now negative charge will attract or repel. It will attract, beta. So it will EA. Now the one question arises, the electric field intensity due to B point and electric field intensity due to A point, which is more stronger, where the distance is very less. So here distance between B and P is very small than the distance between A and P. So this electric field is more stronger than this electric field. So if we want to find out net electric field at point P, what we will do? Simply subtract weaker value of electric field from the stronger value. We will find the magnitude as well as direction also. And this is the strong electric field, so I can write here now, this is E net. This is net electric field. Now, one thing only left, and that is what? We want to find out the magnitude of this electric field. For that we require distance from the center to the point P, and let we have considered it as R. So now when we have already find the direction of net electric field, simply we require the magnitude. Now I am telling you how can we find the magnitude. See, here the value of electric field due to point A is equals to 1 upon 4 pi epsilon naught Q upon AP square. What is AP? This distance from the center to A is L, and this is also L. And from center to point P it is R. So R up to here, and this distance is L. So what is the value of AP? See, EA equals to 1 upon 4 pi epsilon naught Q upon R plus L whole square. This is our equation number 1. Or you can write, instead of 1 upon 4 pi epsilon naught, you can write directly K also, beta. And in case of B, you can write 1 upon 4 pi epsilon naught Q upon BP square. What is the meaning of BP? BP is R minus L equals to BP. So we can write EB equals to 1 upon 4 pi epsilon naught Q upon R minus L whole square. This is our equation number 2. Now then, how we have find the net electric field direction? Same we will apply in case of magnitude. We subtract A electric field from B. So here E net we can find equals to magnitude of electric field at point B minus electric field due to A. So now we can write E net, or you can say simply E equals to 1 upon 4 pi epsilon naught is common, Q is also common, so we can write 1 upon, you can say Q upon 4 pi epsilon naught, B value come first, so this value come first, so you can write here 1 upon R minus L whole square minus 1 upon R plus L whole square. Again, what will equals to Q upon 4 pi epsilon naught R minus L R plus L write this manner. And then we can write r plus L whole square minus r minus L whole square. Now if we solve it, what we can write here equals to q upon 4 pi epsilon naught r square plus L square plus 2RL minus r square plus L square minus 2RL. And here we can write r square minus L square whole square. Finally, what we can write again? See, if we open this bracket, then the sign inside the bracket will change. So how can we do this? We can write equals to q upon 4 pi epsilon naught, then r square plus L square plus 2RL minus r square minus L square plus 2RL. So we can write here r square minus L square plus 2RL, and here we can write r square minus L square whole square beta. See, whatever the values are here cancel out, you just cancelling it. R square cancel out with R square, L square cancel out with L square, and then we can write equals to q upon 4 pi epsilon naught 2RL become 4RL, but I can write 2L into 2R because I know what I want in my next step. Here you all know that Q into 2L is what? Electric dipole moment. So we can write here now equals to 1 upon 4 pi epsilon naught P dipole moment. You can write here 2 also R upon R square minus L square whole square. This is the electric field intensity at any point P due to electric dipole on its axial line. But the special case we have to discuss, and generally the special case comes in board exam, and that is, here we consider if R is much greater than L. If R is much greater than L, then R square is also much greater than L square. So we can write here in this formula E axial equals to 2P R upon 4 pi epsilon naught R cube, and R is cancelled out with the cube, so we can write here square. The final formula is E axial equals to 1 upon 4 pi epsilon naught into 2P R square. Now try to understand. When we have found in previous module electric field due to a point charge at any point, there in denominator only R was there. But in case of axial line expression, here the R square comes. So here we can say that electric field at any point on the axial line is inversely proportional to R square. But it is in case of axial line, not in case of a point charge. I think you all understand whatever I have discussed here, and if you have any problem you can contact me. And this was all about related with my today's module. In another module I will come again. Thank you. Have a nice day.